OHAI. According to the National Research Council of Canada's official Canadian time, it is now 6:30 p.m. Welcome to the OHAI Working Group. I'm Richard Barnes. On the screen, you can see my co-chair, Siobhan Sahib. And I think Siobhan will kick us off with a few administrivia.
Thanks, Richard. Welcome all. You have probably seen this slide several times during this week, but it is really important, so please do note it well. It covers several topics such as patents and code of conduct, and please do feel free to reach out to Ahmed's team if you experience behavior that you're uncomfortable with. And the note will also cover several BCPs and documents that describe participation in the IETF. Just some meeting tips. The important one here is that please use Meet Echo to join the mic queue so that we can keep things fair between remote participants and in-person participants. And if you're not using the on-site tool, please do record your participation using the QR code that's probably up there somewhere in the room. And if you're joining remotely, this should also already be taken care of. And yeah, make sure your audio and video are off unless you're presenting if you're a remote participant, and use a headset. We have some note takers. Thanks to Laura and Chris for helping take notes. And yeah, we can begin. Tommy will be talking about deployment experience with OHTTP, which will lead into the chunked OHTTP draft discussion, which is our adopted draft for now.
And just quickly check before we launch into it, any proposed changes to this agenda? Are we all good with this? Sounds good. All right, Tommy, take it away.
Okay. Maybe even be quick so we can let people get to their dinners or whatever else lies on the other side of OHAI. All right. Great. I'm Tommy Pauly from Apple, and so first I wanted to share some background on the experience that we've been having with a couple different use cases for Oblivious HTTP, just to see kind of how they're set up, how they're configured, how they perform. And I had specifically asked to actually do this before our discussion on chunked OHTTP, because some of the details of how we actually deploy these things and test these things and what we've run into are relevant to what we think we should be doing in that draft. Okay, so I'm just going to first go over 3 different use cases where we are employing Oblivious HTTP, and then talk generically about how we're doing configuration for OHTTP and how that's being shared. All right, so the first one that we've been doing for the longest period of time is for doing safe browsing type checks. And this is like an example of like an iOS UI for what it would look like in Safari. So this is a protocol that previously already existed. You have cases where you have a big database of truncated URL hashes that indicate buckets of things that may be phishing or malware or some bad type of sites. And so those are downloaded periodically. And then if a client has a hit on one of these truncated hashes, they go and fetch the complete bucket of complete hashes and figure out if the site they're going to is potentially malicious, and then they will show this thing. And it's very important to have privacy on these checks because when you are, well, you're fetching these things in the background quite a lot, and so this would allow the server to just kind of like watch where everyone goes. But also, when you actually do a lookup here for something that is potentially on the list, that is revealing some information about what you may be accessing. So it's very important to have good privacy here. So the overall setup that we're doing, so we have on the left, I have 2 clients just to represent. There's a multitude of different clients, and they are communicating generally over HTTP 3 by default. It can fall back to HTTP 2 if UDP is blocked on your network, but generally it's HTTP 3, and these are somewhat long-lived connections in the background from the browser client going to the relay, which is operated by a third-party partner. And then there's a pretty long-lived connection, or a set of long-lived HTTP2 connections that are mutually authenticated with TLS between the relay and the OHTTP gateway, which is also where the safe browsing service target is. And then the clients are authenticating to the relay using a privacy pass token. So the clients need to kind of be able to fetch that ahead of time, just to say they're legitimate clients that are expected to use the service. And for this case, there's no actual authentication to the back end there. And as I mentioned before, there's like a periodic update that happens in the background, and then some more real-time updates when you have a potential hit. So just some of the properties here. These are normally, because they're in the background and periodic, it's normally a cold start connection. So like these fetches are not reusing connections that much. They're just kind of creating a new connection to the relay. It's predominantly in the background. Most of the time, this latency is not actually blocking users. I think the frequency we see for people actually having a potential hit is like once a day. So normally this is just like a background thing. And when we look at the times for downloading that whole database, globally, over OHTTP, we're seeing it be like on average like 350 milliseconds for the whole thing, which is okay. It's a background thing, so it's not super important to optimize further than that. So that's one example of OHTTP here. There's another case which was actually discussed at the last IETF, I believe, when we were talking about some of the cases where we could have this like unreliable OHTTP. This is for like DAP metrics upload. In this case, you're just trying to essentially post and upload of things to the server. The responses are not used in any way, and so this is a case that could be optimized by allowing the client to just hand the message off to the relay and then not care if it actually got all the way to the gateway or was accepted. They just want to shove the metrics up. In this case, there actually are two sets of privacy passes going on here, but otherwise it's a very similar setup, and it's like on the order of a day or a couple times a day that this is happening. And then the newer case that we have that we're using is for model inference. Recently we announced some private cloud compute features for various generative AI things. There's a blog, you can read about all the details there, and it explains that it is using Oblivious HTTP. And this is a case where you have potentially large responses or small responses, and they take a varying amount of time to generate, and there's a lot of value to having the beginning of a response and then be able to trickle in the rest of the large generated response over time. But again, it's a very similar setup. You have many clients with reused and longer-lived HTTP3 connections. They're using a privacy pass to the relay. There's also a separate privacy pass that's being used all the way to that inference server. There's a mutually authenticated HTTP2 connection in between. And this is more real-time based on user activity when a user would be using some of these features.
Tommy, quick clarifying question.
Yes, sir.
The gateway privacy pass here and in the, I think the prior example, is that held by the relay, or does that kind of pass through
good
from
point.
the client through the
Yeah,
relay?
it's an end-to-end. So it's within the encrypted HPKE package that is decrypted by the server. Yeah, that's right. So it's saying that this client has access to that. It's also a way to provide some rate limiting, where if you limit how many gateway privacy passes the client can do, that kind of controls how many AI inference operations they can do on that model. So this one is more different. It uses chunked OHTTP, and that has new features that comes along with. And in this case, previously we had been doing the other features, and we didn't have to implement things like indeterminate length binary HTTP. We didn't have to have binary HTTP trailer support, because if you're doing single messages that cannot be decrypted partially, there's no value for trailer fields. since you have your header fields always in the same bucket. And so these were things that in deployment experience and implementation experience, until you start doing chunked, you really aren't really exercising what it means to do indeterminate length binary HTTP and to have some of the other features like trailer parsing, etc. So just heads up, things to test. And one of the other interesting things we'll talk about later in the chunked OHTTP draft is that when we were testing this through different CDN provided relays that were doing the chunked OHTTP relaying, we found it very common that by default with post, they were doing buffering of the entire message and waiting for the end of the message before they would send any bytes up to the server or back. And that is kind of defeats the purpose of doing chunked. And we're like, well, this is not giving us the performance we want. And it's like having some really huge delays in these cases. And they were all relatively easy to fix, but is something that is also not obvious if you're just doing the normal Oblivious HTTP with a post that's all in one go. So those are the 3 different use cases we wanted to share. As far as how we do the configuration and how we do that deployment, we have a configuration bag for kind of all of the Oblivious HTTP servers that we know about and their associated relays, and we fetch that every like 12 to 24 hours to get updates there. And this bag includes the different OHTTP configs, and each of those has the gateway key configuration, and that's the thing that is in the normal OHTTP draft or the RFC. It also then says, here's the relay that you need to go through and like the path on the relay for the relay resource. It indicates kind of like, what are the supported targets that I can get to behind this gateway so I can know how to route them. And then it also indicates whether or not you are supposed to be using chunked or non-chunked for this particular rule. And if you look into some of the stuff we're doing for the private cloud compute features, there's a lot in there around trying to make sure that there's non-targetability. And so these configs are also being replicated into a transparency log, and we're validating against that. And so that's another aspect of this config. So this is essentially one model of how you can get the information about OHTTP. And it's definitely kind of like the driven proprietary config that the client knows about and is fetching, but it is a way that does work. And I'd be curious to hear if other people have experience with other mechanisms and if they are similar or different to this. And that's all I have here. Any questions?
Any questions, comments? Yeah.
I had a question, Tommy.
Yeah, sure.
If you go to the previous slide, you mentioned the transparency log. Can you say more about this?
So, I mean, this is essentially like alongside the OHTTP configuration, there's like some proofs that you can check in a transparency log that is all detailed on like the private cloud compute stuff. That will do a better job of explaining some of the details than I can. But yeah, it's essentially just like a blob that you then verify is in the transparency logs. It would be similar to like a key transparency type solution. It's just a bigger bundle of things.
I guess just wondering if you think this is something worth generalizing, and because this question comes up during OHTTP discussions, do you feel like this would something that could be used beyond, or could be in a draft or something?
Yeah, I think it could. I think it'd be worth exploring, and also kind of hearing from other people who may be trying to use OHTTP if this is an approach that they are looking at taking or expect to take. Because I know we've had discussions about, can you do transparency to provide the consistency, or do you do other things like a double check? And so in this case, doing the transparency log was what we went for this architecture, but I could see other more dynamic cases being ones that double check would be easier on.
All right. Other questions or comments? I'll leap to the mic. Thank you for this
All right, now the document.
unusually large amount of information from Apple.
Okay. So now we'll be talking about the chunked Oblivious HTTP messages draft, which is on 01. So just as a recap, and we kind of mentioned it in the last presentation, chunked OHTTP is about allowing you to encrypt and decrypt the requests and responses for OHTTP in separate chunks. And so the layout of it is you have the existing kind of request header that you have, and then on the responses, the header is just a nonce. But instead of one HPKE or AEAD encrypted response, you have a little length field that goes before each chunk, and you have multiple chunks. It's a very straightforward idea, but it has, as with everything, many complications in the details. And as I mentioned before, this allows use of indeterminate mode of binary HTTP. It uses the built-in support from HPKE for having multiple messages, and conceptually is still just a single HTTP request and response. It's not a unlimited streaming bidirectional thing. It's just a way to not have to do the entire message all in one go. Yeah. So things that were changed in the 01 version, we fixed one issue, which was an easy one, so we did it, around how many chunks you could have. HPKE already does this correctly by having a max number, but the responses also needed to specify the same thing. Your counter should not exceed the values that you could store in the nonce for uniqueness, since that would cause nonce reuse. So don't do that. There's some other to-dos that we have of doing the test vectors and some of the protocol formal analysis that just need to get done when we have time, which we don't have. But the most interesting issue that has had discussion that I wanted to highlight today is the one that I was hinting at for the deployment experience, where you have incremental forwarding issues on the various CDNs that are handling the post messages for Oblivious HTTP. So our deployment testing found that most of the common implementations did buffering for post and would wait until you had completed your entire request, or wait until you got your entire response before forwarding on any of the bytes. So that, as I mentioned before, does render the chunked mode pretty ineffective. And so we have good discussion on the issue. Kazuho pointed out a lot of great things in the discussion, and we were going back and forth. So one of the references that is useful here is from RFC 9110 on HTTP semantics, and it points out that while the HTTP message can be parsed as a stream for incremental processing, the senders and recipients cannot rely on that incremental delivery of partial messages, since the implementations can buffer or delay the message forwarding. So that's exactly what we're hitting. It is up to implementations to do what they want to do. It is allowable, equally allowable to have incremental processing as well as buffering. So there are a couple different options for what to do here. One option doesn't involve anything much about the actual spec, other than maybe giving some advice, but you could essentially just say, do what we did so far and fix the servers that are doing this. Like, if you know you are going to be used as a chunked OHTTP relay, you should not be buffering those post messages. So simply, like, those intermediaries that are being used for this get updated. We could just give some advice in the document and say, if you want this to be effective, don't buffer. And if you have a deployment that is buffering, you just ask them to stop doing that. For the cases where, as what we've seen so far in this deployment experience, there's a pretty concrete setup where a client is getting a bag of like, here are the known relays that you should use in this mode, and here are the gateways they work with, and they're all authenticated with tokens or mutual TLS. This works okay. It's not super elegant, but it can work. The other second approach would be like a much bigger design fix. One of the things that was brought up on the issue is like, well, post is much more common to have buffering, but there are things like connect that obviously don't do the buffering, and so you could like switch OHTTP, or at least this mode of OHTTP, to stop using post to use extended connect instead. But that really changes the protocol quite a lot more. It loses a lot of the advantages that you have of just saying, I want to use more normal reverse proxying capabilities that are built into CDNs or built into other existing intermediary infrastructure without having to switch all the way over to a very different type of forward proxy. So we could do this. It would be a large change and would cause more divergence between different modes of OHTTP. And then the third option, which was more recently suggested, was to just have a negotiation fix where the clients and servers can agree about what they're doing for buffering in posts. So this is just saying like, hey, I'm doing a post and I would like you to not buffer this and actually be explicit about it and not just rely on the fact that this is chunked OHTTP and you hope that the intermediary knows that that means they should not be buffering. So Kazuo has this week come up with a proposal for a negotiation fix. It's very simple. It's essentially just a new header field that the clients would send in a request that would indicate that the content should be streamed instead of buffered. The proposal in what he was saying, I think, was request streaming, and it's equal to 1, or maybe it needs to be, I guess, $1. Yeah, sorry. But a very simple thing, and so we can absolutely bike shed what the name of that should be. But I think we want to get feedback on, is this, of the 3 directions, is this the right approach? And then there's also a larger question of like, where should that work be done? Because this could be a very generic thing that could be done in HTTP BIS because it could apply to really any application of post or many other methods to let clients indicate that they would prefer not to have their requests buffered.
All right, we have a couple folks in the queue. Piotr, please.
Piotr Sikora. 2 comments. So, first on the negotiation fix. Historically, reverse proxies used buffering of the post or other long-running requests as the DDoS protection, or like general protection against generally less performant backends, right? So doing negotiations kind of like defeats this purpose. Second thing, what was the second thing? So this is not unique problem to Oblivious HTTP. Notably, gRPC in streaming mode is basically one big post request that does this back and forth. So I'm actually surprised that this was an issue for you in the deployment, and I would suggest that force your CDNs to stop buffering.
So you go with like the first fix of just fix your thing.
Yeah, let's fix it.
Fine.
And on negotiation fix, you don't need to introduce separate header. If you wanna do that, you can just base it on content type, right? Right, and if it's Oblivious HTTP, just don't buffer.
Right. I mean, do you know for cases of, like you're mentioning, that already don't do the buffering like a gRPC, is that based on content type?
I don't know.
Okay. Yeah, and just one other thing I mentioned, like I totally get that oftentimes the buffering is for DDoS prevention and other things. I imagine, again, like this is just a hint or a request, and it could trigger the logic to say, okay, evaluate if this request is sufficiently trusted to do that. Like in this case, as I mentioned before in the deployment, like we're giving you a privacy pass that's been rate limited, and we're going to a known upstream that you have a mutual TLS with, and like all of these things that should make it past the check, which of course you could just do by saying, yeah, the deployment just has to know that this is streamed, but it can be nice maybe just give another hint of like, yeah, on this particular request, I do expect it to be streamed in chunks without having to do different content type sniffing. But I don't know. I think it's an open discussion.
Kazuho. So as Kyoto said, this streaming is not specific to just chunks or HTTP, but it also exists with other application protocols such as gRPC. And for what's worth, the best practices for HTTP, the best practices document says that application protocols have to be developed in a, well, content type or method or whatever independent way, meaning that requiring specific tuning to the proxies is not a very good way of developing protocols. So I very much prefer having this kind of discussion in the HTTP working group and fixing it as an extension, because that paves our way forward for having a specification that is, I'd probably say compliant, and it might be a too strong word, but something compliant to the best practices that we have for HTTP.
Jana Iyengar, Fastly. I agree with what Piotr said, except that he certainly took a left turn and went to a different conclusion. So I do agree that this is a more general thing, and exactly what Kazuo said. I won't repeat it. But I have one question. Does this, the request streaming of one, does it result in an error if it's not supported, or is it a silent failure? So that might suggest, so that's probably,
what do you think, Kazuo? Silent, yeah.
So silent failure. So I think this is exactly the kind of thing that I agree they should go to the HTTP working group, but I think this is the right direction.
Yeah.
And I wholeheartedly support it.
Cool. Great. And again, like in this case with chunked OHTTP, yeah, if you don't get the streaming, you're just delayed. It's just slow. You're just having a sad day. But the request can work.
So it does depend on whether it deadlocks or not. It depends on the application. I mean, like in particular.
Yeah. So in some of the tests we had, we would hard fail on that.
Right.
But generically with chunked OHTTP, that could work.
I see it.
If the client was tolerant of it.
The reason that this should be discussed in the HTTP working group is because it won't be discussed in the context of just a particular chunked HTTP. In the general case, you have to make sure that the semantics are clear to the applications and they have a way of recovering from lack of support.
I think the examples of existing things like gRPC that have similar properties that are also not using extended connect, et cetera, are similar. Like, and we can argue that they should all move over to using web transport, like something like that. But the reality, does exist that you have non-connect protocols for which you don't want full buffering.
I just put myself in queue to say that these options you presented are not actually mutually exclusive. Even if the HTTP working group makes us a signal, something like this that you would use to request this behavior, you could also say that, like, regardless of that, this protocol works better if you don't buffer.
Right. I think the deployment fix and the negotiation fix are, you can always do the deployment fix. If we take a really sharp turn over to say like, we're going to give up on post, that's a much bigger design change. But yes, I think we could go with both. It sounds like people would agree that this should be a generic HTTP thing. I probably would argue that we would want to normatively reference that extension, and so share our fates across the working groups. But yeah.
Jonathan Hoyland, Cloudflare. So is it permissible? I promise this does have bearing on the question at hand.
It's permissible, but
is
not
it permissible that the client continues sending chunked request data after receiving the first byte of the chunked response?
this is something that in the document as it stands today is permissible. It is an issue that is open. I don't think we've like fully closed on it. When we were originally discussing the document, I think some people were of the opinion like, oh, we want it to be less streaming, like less bidirectional. From a protocol standpoint, and I believe even from like an analysis standpoint, like it should be safe to do that. It's more about like, what do we want the world to look like?
So yeah, from a security analysis standpoint, I think it should be required that the intermediary buffer the entire server response, because otherwise you can implement bidirectional streaming if you want it.
But if the client has completed its entire request.
Sorry, yeah, until the client has completed its entire
Sure,
request.
right? But like I could stream up my request, and then you could stream down your response.
Yeah. I mean,
And those should not involve buffering within each of those segments.
yeah, sorry. What I meant was you have to wait until the whole request is received by the intermediary before you start sending the response.
So
Yeah, because
Just-
otherwise imagine you are just being dumb and you decided, I'm going to implement bidirectional streaming by calling it one very long request and receiving part of the response and then sending part of what's effectively a new request.
right.
Right, but that's not what you want, right? You're trying to get oblivious here,
Right.
not...
So to clarify, because the main problem I can think of with that from the privacy aspect is that now you are definitely able to reveal a lot about timing and other things that could help you infer location.
And you're just sort of completely linking the...
Well,
Right.
yes, right. You are linking all of those. So I see it as a privacy regression, but from a cryptographic security standpoint, it should not be regressed. Like the
Really? From what I understand of the analysis, it would be once the client is able to start responding to things the server is doing, the guarantees all go out the window, basically.
the threat model of re-identifying, or well, obviously, like you will re-identify everything that client does on that post request, but like any threat model about identifying the client or potentially even pinpointing the client's location, et cetera, totally agree that becomes all opened up. But like the security from an attacker being able to decrypt or
Oh yeah,
like
yeah.
that doesn't
But like
change.
from an unlinkability standpoint, it seems
yes, it's just the link. Yeah, right. Yeah, agreed.
Thank you.
John, I noticed you got up, but you didn't join the queue. Did you have feedback on that?
No, go on.
Cool. And I think the kind of like the text around those implications is something that needs to be worked on based on the issue.
Okay, if, Thibault?
Yes, thank you for the presentation. Maybe one thing which I thought about here might not be totally related is OHTTP does not have like a standard like endpoint, for instance, for like retrieving configuration. So even though like this is this probably won't fit like in a configuration endpoint, but I was thinking if this is something that like could be valuable down the line, if we have like kind of like multiple ways to actually like operate relays. To specify, okay, I would support, for instance, like request streaming, no matter what. I would support chunk OHTTP, or if this should be part of a negotiation.
Right. So previously we've discussed, and I think we still have some open issues around the document to describe the impact on configuration. As I mentioned before, if you have a ad hoc configuration on the side, then you're good. So OHTTP on the main RFC does define a configuration format and a content type for that. And in the OHTTP discovery RFC that we also did, there is at least like a well-known URI that you could go to ask for a configuration. Now that configuration format does not include bits like, does this gateway support chunked? And of course it doesn't include anything about the relays that you may go through to get there. So I think the relay discussion is, I think, a bit orthogonal because that's just like generally how do you discover relays and how they relate to gateways, which probably doesn't belong to anything about chunked. But what is definitely an interesting question is, do you have a different content type or like a way to know that this gateway is supporting chunked specifically? Does that make sense? Okay. Cool. Yep. So overall, we still have to finish some of the updates based on the other issues, which we alluded to here, which we got some feedback on at 119, but we need to do more thinking on. That includes, are there maximum chunk sizes overall? How we recommend getting the configuration of do you do chunked or not? The other main thing to do is now kind of go forward with incremental forwarding. And that's probably going to look like a new draft within HTTP BIS that then gets normatively referenced from here. And I also want to call out that it's always great to do more interop, more testing. There are already multiple client, like test client and production client, as well as relay and server, gateway server implementations of this. But I think if anyone is interested in also doing interop testing, there should be plenty of implementations that we could try.
Tommy, do you know if any of those implementations are open source right now? And secondary question, should we be documenting this interop somehow?
Yeah,
help other
that
folks
could be
join in?
interesting. So I know Chris had an old like Go, OHTTP Go repo, and then it has a branch on it with a PR that is not yet merged, but is functional for doing chunked. So that one is open and just public. I don't know of any others that are open and up there. I've heard that Martin Thompson intends to update his implementation to also do this. So there would be at least 2 fully open ones that should talk to each other. Okay. Anything else?
Any other comments? Any of these feedback points that would merit any discussion here? Or do you have a concrete direction on those already?
I mean, if anyone has particularly strong opinions about like configuration and should the configuration be extended to include, do you support chunked or not? Should it be like an entirely different configuration content type or something else? Love to hear it. I think there is some analysis to be done there about the privacy implications of having, if you did purely opportunistic attempts of doing chunked to gateways you didn't know about, that could end up segmenting user populations or client populations based on like which ones ended up learning about chunked and which ones didn't. And so there's all these fun aspects that could come up there, which to the earlier discussion, like don't really come up when you're just like force pushing the information to clients of like, you shall use this gateway with chunked and that is the only way you shall ever use it. So more dynamic cases are trickier, but I think it's also good to understand what real deployment scenarios people are thinking of that would have those types of problems, because it's hard to design without that. Peter.
Piotr Sikora. Maybe this is a silly question, but are you expect different chunk to be sent via different third-party relays and like combined on your end?
No. The chunks are inherently on one stream. They are not oblivious to each other. They are just one request and one response that just are processed incrementally.
Would there be any benefit in terms of privacy or whatnot to use multiple relays?
I think the problem is that if you think about these as different contexts or kind of partitions of information, the communication channel between the client and the target is kind of one connection. So if you end up rerouting that, you need a way to then reestablish and say, like, I am the same one. Then you need like connection identifiers, and then if you're forced to have more identifying metadata that is visible to more parties. Like if you want to go down that road, like multipath quick through mask relays, and like this is not that. This is just like I have a request response that is getting the normal OHTTP benefits, but it's slow because Gen AI can be slow.
Yeah, thanks.
That's it. David.
David Skenazy, Google. I'm assuming you're developing this on GitHub.
Yeah.
The link isn't in the draft. If you can fix that metadata.
Sorry.
No, yeah, because I would have just filed an issue, but then I'll find it. I'll file an issue, but I'll tell you what
It should be
is
on
right
the
now.
working. It's in the working group GitHub.
It's on the working group one. Okay,
Yeah.
I can find it there. It was the point that I made after the interim about how this lacks perfect forward secrecy compared to other solution for streaming protocols, which is a perfectly fine thing. You've now well justified that it's worth the risk, but I think that should be pretty clear in the security consideration. So I'll file you in an issue.
I think you previously mentioned wanting to explore, if you can have perfect forward secrecy with the OHTTP, which
you
good
can,
on you.
You can have it for free for X25519, but for all the post-quantum stuff, then life becomes a lot harder. You have to spend a bunch more resources to do it. And it doesn't sound like folks are particularly clamoring for it. So unless there's a use case, I don't think I'll write it up. So.
I'm hearing people getting wound up about this particular difference in privacy from non-chunked OHTTP. I was trying to, I haven't read the draft recently, but it might be worth pointing out in the draft that the idea is that this basically depends on the application and what the application cares to do. The solution you are describing, ultimately, you are breaking this up and then establishing context through an identifier, which is fundamentally, you're creating that linking because the linking is necessary for this to work. So privacy only makes sense when you think about privacy within the scope of it actually working. If it stops working, then privacy doesn't make sense at all at that point. So that might be just something worth noting in the draft if it hasn't already been.
Yeah, I think that's an area like this meta discussion is worth more clarified text. So Jonathan.
Jonathan Hoyland's Cloudflare. I agree that this is it's not necessarily bad. The question is more, we need to be sure we know what guarantees we're actually trying to provide, especially if you're going to get a formal analysis. We would have to actually say that the guarantees are different. That if you're doing the whole
Different from
non-chunked, which doesn't mean bad, it just means different.
Yeah. And I imagine in the case where you are not allowing interleaving of request response chunks, particularly when you just have streaming response chunks, the information disclosure is really very, very similar to unchunked.
If you keep the restriction that the intermediary buffers until the client request is completely received, then I think it's the same.
Then I think it's identical, right?
Yeah.
Now I don't think that's always desirable.
Sure.
So we could, but I think having the discussion of these are the properties you get if you do it this way, and not. Because the client could always choose to send a single chunk that is complete, and only receive multiple chunks of response. That's a perfectly acceptable use of this.
All right, we've reached the end of the queue. Last call for any discussion on this draft. Going once, going twice. All right, I think in that case we are adjourned and everyone can enjoy their dinner. And Siobhan, we'll see you next time.
Yep. See you all.
going to chat with Sean.